Hello everyone. Today we are going to learn grade 9, chapter 10, electrolysis. I am Rashida Farvi. What is electrolysis? Before we go through the lesson, here there are two terms which you might know already in your previous grades. One is electric cell and the other one is electricity. What is an electric cell? It's an electrical power supply which convert chemical energy into electrical potential energy. And electricity is a flow of electrons around a circuit. Here, for example, for electric cell, you can say a dry cell or a battery. In this lesson, we will learn three more terms which are electrodes, electrolyte, and electrolysis. You must understand the difference between all these three. Right, let us look at these three diagrams. Here, all three look similar, but here in each beaker, we have three different substances. In the first one, diagram A, we have distilled water, and in the second one, we have positive and negative ions fixed in a solid. In the third one, we have a solution which has mobile ions. Right. So when we complete the circuit, you can see here the bulb is still off, here the same, but in the third one, the light is on. What's the reason? Right. It is because in the first one, we have distilled water. So a distilled water doesn't conduct a current. In the second one, we have positive and negative ions fixed in a solid. It doesn't conduct current. But in the third one, we have a solution with mobile ions, so it conducts current. So why here you can see these two, they have ions, but a solid doesn't conduct current, but a solution, it conducts current. Why? Here you can see the diagram of a solid, how these positive and negative ions are fixed. They are fixed in lattice, so they cannot move, so they can't conduct electricity. But how can we make a solid to conduct electricity? Here, there are two methods. One is by heating. When you heat a solid state, it becomes liquid. We can call it a fused substance. Remember the word fused substance. And in the second one, when you dissolve an ionic compound in a liquid or water, it becomes aqueous solution. So there, it conducts current. Here you can see in a molten or aqueous solution, how these positive and negative ions are. They are free and they can move, so they can conduct electricity as well. Right. Does all liquid conduct electricity? To find out, let's do this activity. Right. Here, we have a setup with two carbon rods, a wire, and a dry cell, and ammeter. So dip these two carbon rods into a solution. Here we take 5 different solutions to check whether all liquids can conduct electricity. Right. So if this ammeter get a current through it, it deflects. So if it deflects, we can say that the liquid conduct electricity. Right. So here we use these 5 solutions. One is kerosene, salt solution, acidified water, copper sulfate, and distilled water. So the solution of salt, acidified water, and copper sulfate, these three, they have mobile ions in them. So when you put the liquid and connect the circuit, you can see there will be a deflection in the ammeter. So you can see those three liquids, they conduct current. But here in kerosene and distilled water, they don't have mobile ions, so they won't conduct electricity. Right. So the liquids or solution which conduct electricity are called electrolytes. So we can identify all these five solutions. Kerosene is a non-electrolyte, salt solution is an electrolyte, acidified water is an electrolyte, copper sulfate is an electrolyte, and distilled water is a non-electrolyte. So let's see what are electrodes. Right. When electricity is conducted through an electrolyte, the conductors through which the electric current enters the electrolyte and exits are called electrodes. For example, you can say copper, carbon, platinum, or any other metal. But what is an inert substance? A substance that doesn't react chemically with the electrolyte is called inert substance. For example, carbon and platinum. Here in all experiment, usually we use carbon because it doesn't react chemically with the electrolyte what we used. Right. Let's see what happened in a solution which has mobile ions. Now, for example, let's take sodium chloride solution. In sodium chloride solution, we have sodium positive ion and chlorine negative ions. So sodium positive ions, we call it cations, and chlorine negative ions, we call it anions. Here in this circuit, you can see this is a complete circuit where the positive terminal of the electric cell is attached to a carbon rod. So we call it positive, and the negative terminal of this electric cell is attached to this carbon rod. So this is negative. And here you can see all the mobile ions in the solution, they move towards the opposite direction, where here you can see the minus negative ions move toward the positive electrode, and all the positive ions, they move towards the negative electrode. Right. So since the negative ions move toward the positive, we call this electrode as anode. Why? Anion move towards anode. And here you can see all the positive ions, cations, move towards the negative electrode. We call it cathode. Remember, anion, anode, and cation, cathode. Right. So here you can see what happened after electrolysis. Here you can see all the sodium positive ions are closer to the cathode, and all the anodes, all the negative ions are closer to the anode. So when an electrical current flow through a liquid which cause chemical change, we call it electrolysis. Right. So let's study the changes take place in a solution by an electric current. So here again, we take the sodium chloride solution where two carbon electrodes are partially dipped and both the electrodes are connected with a circuit and an ammeter. So you can see here sodium chloride solution which has sodium positive ion, chlorine negative ions, and also OH negative ions and H plus positive ions. So here you can see all the positive ions are attracted to the cathode and all the negative ions are attracted to the anode. So here you can see this as well. Here chlorine negative ions, they receive electrons and become chlorine, and all the sodium positive ions, they gain electrons and become sodium. So finally, we can say during the electrolysis process, what happened? Usually, it converts the solution into more simpler components. Right. Here you can see in this activity, we use copper sulfate solution instead of sodium chloride. The same diagram. So when we pass electricity, when an electric current goes through the solution, it becomes copper 2 plus and SO4 2 minus, as well as H positive ion and OH negative ions. So all these simpler components, you can see they move toward the opposite direction. As I told you already, here you can see copper 2 plus ions, they move towards cathode, and SO4 2 minus sulfate ions, they move towards the positive anode. So here you can see gas bubbles can produce at anode, and you can see a reddish brown substance deposited in the cathode. So what is this red substance? It is copper, and here the gas bubbles, those are oxygen. And also you can see a gradual decrease in the blue solution, which is a copper sulfate solution. So why this happens? Because since all these ions move towards the opposite terminals, there will be a reduction in the ions. So obviously there will be a decrease in color. Right. Here I have an exercise for you. Compare and contrast the electrolysis of aqueous sodium chloride to that of molten sodium chloride. In your answer, refer the ions present, the products formed. Here you can see molten sodium chloride, and here you can see aqueous sodium chloride. What is the difference? Since both are sodium chloride, this is molten and this is aqueous. Here, see the diagram. In this one, only sodium positive and chlorine negative ions are present in molten sodium chloride. But here you can see with sodium and chlorine ion, you can see H plus and OH minus as well. So here there will be a gas production, gas bubbles production at both the terminals. Here you can see chlorine gas, and also here you can see H2 gas. Right. So let's see what happened. What happened when we pass an electricity through a acidulated water. Right. Here you can see there's a 9 voltage electric cell and 2 carbon rods, a plastic container, and test tube to collect the gases. And here we have to make a hole in the plastic container and put the carbon rods and seal this with a wax. And then let's add acidulated water, which we have to put few drops of sulfuric acid into water. And then when we complete the circuit, there will be a electricity. So at the end of this experiment, you can see gas bubbles are collected at both these test tubes. Right. So this is the diagram where H plus and SO4, you can see the H plus and SO4 2 minus ions, they move towards the opposite terminals. Here you can see gas bubbles at both the ends. Here at this one, you can see oxygen gas at positive anode, and in the negative cathode, you can see hydrogen gas. Right. So how can we prove that this one is hydrogen and this one is oxygen? Right. If we test it with a glowing splint, if the splint reignites, that is oxygen. And if we test it with lighted splint, if the gas burns with a pop sound, it is hydrogen gas. Also, the volume of the gas collected at the negative electrode is approximately twice the volume of the gas collected in positive electrode. So usually H2 gas, hydrogen gas is twice in oxygen. Right. So here there are some important use of electrolysis. Electrolysis usually it is frequently used in various industries. So one is electroplating, and the other one is purification of copper, and the other one is manufacture of chemicals such as chlorine, sodium, chloride, and bleach. Also, the extraction of reactive metals such as aluminum foil. Right. So let's see what is electroplating. Right. Here you can see this diagram. Here we have attached a copper plate, the positive terminal, and also we have attached the iron nail to the negative terminal. If we connect the circuit, if the electricity pass through, you can see this copper plate gradually dissolves, and you can see a reddish brown substance on this iron nail. So why does it happen? Because the copper sulfate solution here and the copper plate, when we pass the electricity, the copper 2 plus ions, they gain electrons and become copper. So they get deposit on the iron nail. Also at the anode here, all the copper, they lose electrons and become copper 2 plus ions. So that's why you see a gradual decrease in this copper. Also, there'll be a copper deposit on this iron nail. Here, why do we use copper sulfate? So when we do electroplating, we have to use the salt solution of the metal which we use at the positive terminal. So here if we are using copper, we use copper sulfate. For example, if we use another metal, we have to use the salt solution of that exact metal. Right. So the definition of electroplating is the plating of a certain metal on another surface using electricity is electroplating. So here there is another exercise for you. I have given 3 substances. You have to find out what do we use at positive electrode and what do we use at negative electrode, and the electrolyte type which we use. Right, here you can see the first one, we have to place silver on an iron plate. So positive electrode, we use the metal which we want to plate, so that is silver, and the negative electrode, that is iron plate, and the electrolyte, obviously here since this is silver at the positive, we have to use the salt solution of silver, so we can use silver nitrate. The second one, gold on copper ring. So at the positive electrode, we use gold, and at the negative electrode, we use copper ring, and the electrolyte, gold chloride, or any other salt solution of gold. Third one, chromium on tap, positive chromium, negative electrode, iron tap, and electrolyte is chromium salt solution. Right, so here you can see a diagram. Name the metal used as positive electrode. So you can see here silver. What is the sign of the teapot electrode? If this is positive, what is the opposite one? Negative. Which solution can be used as an electrolyte? So here, since we use silver metal at the positive, we have to use salt solution of silver. So you can say it is silver nitrate. What precautions can be taken to obtain a plating of high quality? So you can see here, after electroplating, when you touch it, if it takes off the metal which we plated on the metal, that is not a high quality product. So what should we do to get a high quality plating? Right, let's see. Before that, let's see the characteristic of a high quality electroplating. First one, the coating should be firmly adhere to the surface subjected to plating. The coating should be a firm thickness. The coating should be shiny. Also, for high quality plating, the electrochemical change should take place very slowly. And the second one, by passing a very slow current, you can do a high quality plating. And also, by applying low potential, it can be achieved. Right. So here, the electrolyte salt solution used for this has to be very dilute. Mostly for electroplating, we use copper, silver, gold, nickel, and chromium. So why do we use only these metals? It is because uh, usually we plate these metals on another for some reasons. One is for resistance to corrosion, and the second one, attractive color. Third one, luster and good finish. For example, for copper jewelry, we electroplate gold. It is because it gives a good look, and it uh, when we plate gold on copper jewelry, the value is high. Also, for motor vehicles, we electroplate it with another metal. It is because to resistance to corrosion, to avoid corrosion, we do that. Right here, you can see some other examples: a gold-plated watch, a copper-plated mug, silver-plated teapot, silver-plated goblet, chromium tap. Right. So here in this lesson, first of all, we learned what is electrolysis. After studying what is electrode, electrolyte, we learned what is electrolysis. So electrolysis is a current flow through a liquid which causes a chemical change. And then we studied what happened, what are the changes caused in a solution by an electric current. Usually when we pass current through an electrolyte, chemical compounds split into simpler elements. And then what happens when we pass electricity through acidulated water? Water turns into hydrogen and oxygen. And the last one we studied electroplating. Coating one metal with another metal is called electroplating. Thank you for listening.